subscribe, like and share this channel. The James Webb Space Telescope is now about 1 million miles from Earth, and almost ready to scan the cosmos. The world's most powerful space telescope was ready to uncover the wonders of the universe, but first it needed some help from a little blue truck. The truck had to haul the James Webb Space Telescope, perched atop a more than 165-foot-tall rocket, to the launch pad at a spaceport in South America in late December. Next to the rocket, the vehicle looked almost decorative. I asked Bruno Gérard how the Ariane 5 rocket, standing crane neck tall in front of us, on a platform hitched to the truck, would make the journey without tipping over. Like me, Gérard, a vice president at Ariane Space, which operates rockets like this one, was wearing a blue hard hat and gripping a gas mask. The rocket wasn't completely fueled for launch yet, but its firecracker-like boosters, one on each side, were packed with highly explosive propellant. How was this whole thing tied down? "Oh, it's not," Gérard replied, and my eyes nearly popped out of my head. A $10 billion space telescope was sitting on top of that rocket. Gérard explained that the rocket holds itself down with its massive weight, and rocket crews do it like this all the time. No need to worry. The trek to the launch pad was one of many journeys that Webb has taken since the mission, an international project led by NASA, began 25 years ago. The telescope and all its parts have traveled by truck, plane, ship, and rocket. But the most nerve-wracking leg of its journey was the one it finally completed today, when Webb fired its engines and nudged itself into position about 1 million miles from Earth, 4 times farther than the Moon's orbit. Until this moment, Webb was mostly a marvel of logistics. Now nestled in its final orbit, the Space Telescope is finally poised to be a marvel of science. Over the next several months, Webb will make its last adjustments, switch on its instruments, and start basking in the starlight from distant galaxies. It's all wonder from here on out. Webb, 100 times more powerful than the Hubble Space Telescope, will soon study nearly everything between Mars and the edges of the observable universe. NASA has grand plans to recreate Hubble's famous depth field image using Webb's ability to scan the cosmos in infrared, which should reveal even more distant galaxies. Caitlin Casey, an astronomer at the University of Texas at Austin, once told me that a Webb deep field will resemble the spray of a freshly opened bottle of champagne, a sparkling display, with every amber drop of a galaxy. The travels that brought Webb to its new home began in underground mines in Utah, where the lightweight metal that would become the telescope's 18 mirrors was excavated. Over the years, the material, known as beryllium, was trucked to 11 facilities across 8 U.S. states, first to Ohio, where it was purified, then to Alabama, where it was chiseled into honeycomb shapes, then to California to be polished, and so on. The mirrors and other parts of the telescope were assembled and tested at a NASA facility in Maryland before being driven to Texas for even more testing. After that, Webb was flown to California, where it was fitted with its tennis court-sized sunshade and the propulsion equipment it used to nudge itself into place today. By then, Webb was too big to fit in even the largest cargo plane, so it traveled by ship to its last stop on Earth, the spaceport in French Guiana. The telescope sailed for 16 days, passing through the Panama Canal, to reach the French territory, where the European Space Agency had offered up its launch services. The ship had a military escort, and the travel dates were kept secret to protect against the unlikely, but not impossible, chance that pirates might try to steal the telescope. After years of relying on truck drivers, pilots, and ship captains, Webb was turned over to flight dynamics engineers. These engineers had spent years planning out and simulating the final leg of Webb's journey, so crucial to ensuring that the mission succeeded. Now all this theoretical work is actually coming to life. Karen Rickon, who leads the team at NASA's Goddard Space Flight Center that created Webb's trajectory, told me. Rickon's team was tasked with mapping out a path that would bring Webb to a special spot in space called a Lagrange point. There, the forces of gravity will conspire to keep the telescope in place, allowing it to orbit the Sun alongside Earth, always in contact with home. The exact route depended on how the launch went, and everything that came after. The telescope, too big to fit on any existing rockets, launched to space, folded up and unfolded itself piece by piece while on the move. The flight dynamics team has spent years rehearsing Webb's maneuvers, making sure they could keep the spacecraft on track as it underwent the most complicated deployment in space history. There's no way to physically test something like our designs until it's actually in orbit, Wayne Yu, a flight dynamics engineer on Ricon's team at Goddard, told me. We run simulations, a lot of simulations. The Ariane 5 rocket deposited Webb into space just as engineers expected, and every course correction since, including today's maneuver, has proceeded smoothly. Ricon, you, and the rest of the team haven't had to dip into their reserve of well-rehearsed contingency plans. That logistical success is good news for Webb's scientific operations. The less fuel used to maneuver Webb around, the more would be left to power the observatory itself, potentially extending its operations. We were looking at every single microgram of fuel, Ricon said, making sure the mission had enough to react in case Webb was thrown off course. The space navigator's job isn't over. Even with gravity's help, Webb must make tiny, periodic adjustments to keep itself in orbit around its Lagrange point, known as L2. The forces of other celestial bodies, Earth, the Moon, even planets as far as Jupiter, will tug at Webb, and without any intervention, the observatory would drift off. Ricon and her team plan to conduct a small maneuver every 3 weeks to keep it on course, but that schedule could change. They've never had an object like Webb near L2 before, and they've yet to learn how exactly the spacecraft will behave there. Webb will remain in its carefully maintained place until it runs out of fuel, about 20 years from now. When its tank gets low, engineers might command the observatory to push itself into a higher orbit, to make sure it doesn't crash into any objects closer to home. If that happens, Webb could remain in orbit around the Sun for hundreds, maybe thousands of years. It would no longer be yoked to the Earth in the same way, but its mirrors and scientific instruments could keep working, and Webb could still phone home, you said. Last month, after that little blue truck took Webb to the launch pad, I traveled a few miles inland from the coast, into French Guiana's thick jungle, to go to the zoo with Martin Corinne, an astronomer at the European Space Agency. A day earlier, Corinne had stared into the sky as Webb departed on the final leg of its journey. Now he was studying the leaf-cutting ants hauling snips of foliage at our feet, a miniature simulacrum of what the people who designed and assembled and transported Webb had carried out over the years.